Welcome to Grade 3, Unit 6 Math Overview. During this time, please have your note sheet available that looks like this one and your notebook in order to take some notes and try some examples. All right, here we go on write equations to solve word problems. All right, the first thing to remember are math mountains. Math mountains is a method that you were taught in younger elementary years to help you understand how to put together word problems. Keeping in mind that the top is always the sum or the product, the total of a number, whether you're adding, multiplying, dividing, subtracting. The bottom numbers are called addends if you are adding, or factors if you are multiplying, and those are your parts. So when we are tackling a word problem, we always want to start with our knowns, our known information within the problem. Now we can start by just finding numbers right within without even reading the problem, because that helps a lot of times figure out the information we're probably going to need. But also, while we read the question and tackle it, it gives us that ability to understand if that number is important or not. We always look for the words how many and then the letter right after how many. That's going to be our label or our variable used. So we have knowns of 4, 3, and S. Now, we're going to try to figure out if any of these are a total or a part, and if there's any keywords that give away if we're adding, subtracting, multiplying, or dividing. Andre has friends coming over and he wants to make them snacks. If he has 4 friends coming over and he made 3 sandwiches for each one of them, there's a key word right there, each. Whenever we see the word each, we know we are going to be multiplying or dividing because we're talking about equal groups. How many sandwiches did he make? So the sandwiches is our total, or if we were making our math mountain, it would be the one on the S, or on the top, sorry. That makes the 3 and the 4 both parts. So those would be our bottom numbers. Now, because we use the word each, we're going to multiply or divide. Our 2 known information are parts. So if I have a part and a part, I'm going to multiply. So 3 times 4 will equal my S. This is an equation because it has a variable or a letter that represents a given number. When we write equations, we are never solving the problem yet. And then we find our solution. So we will say S equals, and 3 times 4, which is 12. And then we always need to label word problems. This one would be sandwiches. And I'm just going to abbreviate so that we can move on. The next type of problem that we have are called comparison problems. We can use comparison bars to set up our information, where this is really just like a math mountain again, where our total amount, or in this case, our larger amount, is on the top. Our smaller amount is one of the parts on the bottom, and our difference amount is a part on the bottom. So we can set this up by using our comparison bars. Sophia got 21 coins in a video game. Jeff got 3 more coins than Sophia. How many coins did Jeff get? So now we have to look at, who has more, Sophia or Jeff? In this case, it said Jeff got 3 more than Sophia. So I'm going to put the J for Jeff up top. I'm going to put S for Sophia in the smaller box. Now we know Sophia's amount is 21. We also know the difference amount. Got 3 more. So I'm going to write a +3 in here because the word more tells us we're doing an adding or subtracting problem. And in this case, we would do an addition because we have a part and a part. So we're going to do 21 plus 3, and that will equal our amount. So if we wanted to write our equation, we would write 21 plus 3 equals J. And then we would say J equals 24 coins. Now we could have used C instead of J, but when we're doing comparison problems, it's always good to identify the who in these. So that's why we use the J instead of a C for our variable. Our next topic is situation and solution equations. The biggest thing to keep in mind when you're putting together a situation equation versus a solution equation is the variable is going to be within the equation when it's a situation. It's going to be next to another number. And then in the solution, we want to solve for that variable. So when we put together our equations, situation will have the variable included inside the equation. Solution, it solves for it. So again, we're going to start with our knowns. We know we have 4,156. We have 532. And we have how many coins are not quarter. So C for coins. So now I need to read this problem and find out if I have totals or parts. In a collection of 4,156 coins, 532 are quarters. How many coins are not quarters? So I know that this is my total amount of coins. This is how many parts I have of just quarters. And this will be how many parts of coins are remaining. So if I wanted to write an equation that included C within the problem, I could do 2 different ways. I could say that I have 532 quarters plus how many coins I have equals our total amount of 4,156. That's going to be the best because it kind of equals our total. We have our part. Ooh, my P turned out wrong there. There we go. We have another part, and we have our total. Now, if we want to switch this around to solve for C, we have a total and a part. So we are going to use subtraction because that is the partner to addition. And then we would probably solve this problem out to find out exactly how much C equals. But the main part I wanted to show you was exactly how to find a situation which contains the variable right within the problem, and then the solution that we're solving for that variable. You really have to keep those 2 different situations in mind. Situation, variable inside equation, solution, solving for it. Our next type is comparing whole numbers. We have symbols of greater than. That means the first number is greater than the second number. We have less than, where the first number is less than the second number. And then we have equal to, where both numbers are equal to each other. So if we take a look at our example down here, Step 1 would be to line up our digits. So since I already have one digit written, I like to just add the other digit over by it so that they're lined up on top of each other. And then we can see, according to the highest place value, if they're equal or not. Now, the very first step you should always do is count how many digits. If one of the sides has more digits than the other, you already know which one's bigger. The one with more digits is a bigger number. Another way to prove these answers, besides stacking up, is you count. This has 6 digits. This over here has 6 digits. So now we start with the largest place value. We have a 5 and a 5. So I'm going to cross them out. A 4 and a 4. I'm going to cross them out. A 4 and a 4. I'm going to cross them out because they're all equal so far. Now I have an 8 and I have a 7. I'm going to circle those because that's the first spot where I've seen something that's different. And this is actually where it's going to identify which one's bigger, an 8 or a 7. The 8 is bigger, so I'm going to draw my symbol of greater than. 544,897 is greater than 544,799. This is your good proof by circling where they became different. All right, now's your time to give this a shot. Try these problems out. If you're stuck, feel free to watch some of the videos again. Otherwise, continue on when you're ready to check all the answers and see how to best solve these. All right, welcome back. Mr. Young arranges some chairs in rows. He puts the same number of chairs in each row. So we have the keyword of each there and each row of 7. So I know that we have some chairs. We don't know how many chairs, so C times 7. So this first one works. The second one works, or the third one down here works so far. And is a good word that means addition. Put 7 chairs in the last row, so we need a plus 7 more. And it equals the amount of chairs he set up, which is 70. So this is the equation we would use to solve the problem. All right, in our next one, again, this is where finding out totals and parts are important. 150 is a total, 80 is a part, 45 is a part, and how many yellow flowers left? The Y is also a part. So if I really wanted to look at this, I have a total minus a part equals a part. If I take a total and I'm subtracting all my parts out of it, I would be left with the remaining parts, so that is a yes. We have a total plus a part, and we know in math we can't do a total plus a part. We have a total plus a part. We cannot do that. We have a total equals a part plus a part plus a part. If I do part plus part, part plus part, and equals the total, that equation would work. And the last one, we have a total equals a part minus a part, and we would never do the part minus the part. So that would be a no. In our next example, there are 240 boys, so that's a known, boys and girls on the track team. There are 130 girls. How many boys are there? So we know that 240 is the total, 130 is a part, and B is a part. So our equation, if we are trying to solve it right off the bat, or have the solution would be 240 minus 130 equals B. And then the solution is B equals 110 boys. Down on the next part, we have our knowns. Sarah buys 24 postcards. She sends 6 postcards to friends. She puts the rest in 3 folders with an equal number in each folder. So we have a keyword of sends, and we have each folder. Now, what you should have noticed in this problem is we have more than 3 knowns. This would cause us to have a 2-step or more problem. So the first thing we need to do is we have to take our total amount of postcards, 24, and subtract out the 6 that we sent to friends. And then we're going to take the answer of that and divide it by 3 folders to find out how many postcards are in each folder. So 26 minus 6 is 18, and then 18 divided by 3 is 6 postcards. Our last example works on those situation and solution. So we have a 54, we have a 9, and we have a G for how many grapefruit. Joe packs 54 grapefruits in 9 boxes for shipping. He packs the same number of grapefruits in each means multiply or divide, box. So we know that the 54 is a total, the 9 is a part, and the G is a part. Now, most people can find the solution equation faster than the situation. So you probably came up with this equation first. 54 divided by 9 equals G, because we had a total and a part. So now we can think of this again as the math mountains. If we had a 54 and we had a 9 and we had a G, another equation we could have written was 9 times G equals 54. And that would have been our situation because the variable would have been within the equation. And we found out our answer is 6 grapefruit. If you need to rewatch this video, make sure you took some good notes. Try the IXL skills plan for grade 3, unit 6. And remember, there are the lesson checks in the Math Activity Center on Think Central. Good luck.